Alright, this is the last section in the last chapter of this entire quarter. Alright, section 13.4. So we're dealing with definite integrals and we're dealing with word problems. So we'll be dealing with total income, continuous income streams, present and future value of those. We'll be dealing with consumer surplus and producer surplus. Alright, so a continuous income stream. For example, an oil company's profits depend on the amount of oil that can be pumped from a well. Thus, we can consider a pump at an oil field as producing a continuous stream of income for the owner. Because both the pump and the oil field, quote, wear out with time, the continuous stream of income is a function of time. So F of t is the annual rate of flow of the income from this pump. So when they talk about rate, typically that means derivative, so we'll probably be taking the integral of that function. Then we can find the total income from the rate of income by using integration, exactly. In particular, the total income for k years is from 0 to k, f of t dt. Alright, so example 1. A small company considers the oil well, and they have a continuous income stream, and they want you to find the total income from the well. So they tell you it's over 10 years, so you know it goes from 0 to 10. And they give you the function, so you just have to integrate it. And you got to line up your u and your u prime properly, and you got to divide out the number that you add there so that it stays the same value. And then when you integrate and plug in that number, round to the nearest second decimal place, you get 2,594,000. Then there's present value of a continuous stream, and it's a formula given right here. So you just take the formula they give you and you plug it in along with multiplying it by e to the negative rt, and r is going to be your interest rate, and you got to write it as a decimal, so divide it by 100. So here they give you the function here, and they tell you the r is 10%, so 0.1 or 0.10 is your r. We're talking about, I believe, the first 10 years, so you're going from 0 to 10, 0 to k, where k is 10, and your f of t is this guy here. So you plug that function in here, you got this guy from your formula, right? And you plug in there for r, the 0.1, so it's negative 0.1 t. And when you multiply two things that have the same base, you can add their exponents. So you've got a negative 0.2 t when you multiply this out, and a negative 0.1 t. And when you add those, you get negative 0.3 t. And you also have negative 0.2 times 5, which is negative 1. Alright, so there's your exponent, and that's your u, and your u prime is negative 0.3, so you got to introduce a negative 0.3 and divide out a negative 0.3. So then when you multiply those out, you get negative 2,000 out front, and this guy is already of the form e to the u prime dt, so when you integrate, you just get e to the u. And now you just plug in 10 and 0 and subtract, and you get your answer. Future value of an income stream is a slightly different formula. This guy here. It's very similar to present value, but it's got that e to the rk out in front. Remember, r is your interest rate. In this case, r is 0.06. So you plug in 0.06 for r there and there. You plug in the function there, which is 1,000 e to the 0.02 t. And like we did before, you can combine those two because you're multiplying the same base. You add the exponents and you get 0.02 subtract 0.06 is subtract 0.04. Alright, so if you let that be your u prime is negative 0.04, so you got to introduce that negative 0.04 and divide out that same number. And all of these numbers here are constants, they stay out front. And this guy, when you integrate, you just get e to the u, whatever u is, and you integrate it from 0 to 4. And now you plug in 4, and then you plug in 0 and subtract, and simplify it down, and you get this amount of money. It happens to be in millions of dollars. Consumer supply is this formula here. Remember that f here is your supply function, and your p and your x are is the place where supply equals demand. The x coordinate is called x1 and the y coordinate is called p1. Alright, so when we integrate this, we'll have to calculate x1 and p1 so we can know what our limits of integration are, and we know what this term here is. We'll be given this function here, and so we just have to integrate it. Alright, so they give us the function f, and they give us the price p. So we know p, but we don't know x, so we have to find x1. So you plug in 20 in for p and solve it, and you get x is 50. So now you know your equilibrium point x1, p1 is 50, 20. They gave you 20 to start with in the question, and we calculated 50 by plugging in 20 into the function itself. Alright, so now we got our x and our p. Now we can just plug all this stuff in, and so we get 0 to 50 because x is 50. We get the function dx minus p times x. And when you integrate this, you're going to be doing natural log, because this is let your u be the denominator, and so the numerator is just 1 dx. The u prime is just 1 times dx, and so this is of the form u prime over u dx, and that's the form that will give you the natural log. Remember, it's also absolute value. And it's from 0 to 50, so you plug in 50 into there, plug in 0 in there, and you eventually will also subtract 1,000 there. So you get natural log of 51. You don't have to do the absolute value because 51 is positive. You get natural log of 1. Again, you can drop the absolute value. Natural log of 1 is 0, by the way. So you just get natural log of 51 here times 1,020, and then you subtract 1,000, and you end up with 3,010.46. Consumer supply. We first have to figure out what our x1 and p1 are. So we set supply equal to demand, and we throw everything to one side, factor, throw out the negative because x is the number of units and you can't have negative units. So x is 4, and then you plug it back into either equation to get the p, and you find it's 5. So you got x1, p1 is 4 and 5. So 0 to x1 is 0 to 4. And you take the function in there times dx, and you multiply the 5 times the 4 after it, because you've got to subtract that term, p times x. And now we just integrate this guy, and since this is our u, we need our u prime to have a negative 6 in there, so we have a 1 over negative 6 out front. When we integrate, we get this, and we plug in negative 4 and 0, and we subtract, and we get this number here, and it happens to be 4.222, but it's in thousands of dollars, so it's really $4,222. Monopoly market. We must first find the point where the profit is maximized. So they give us the price, but they don't give us the revenue, but the revenue is simply the price times x. So if the price is 300 minus 0.1x, you just multiply that function times x and you get your revenue. Your cost is given. They give you that. So now if you get revenue and you got cost, you take the difference and you get your profit. And now you take the derivative, set it equal to 0, and solve. And that's a critical value. It's possibly where the profit is maximized. You can either use a sign diagram or you can plug it into the second derivative. And that's what I do here. I take the second derivative here and I get negative 0.6, which means no matter what value I plug into the second derivative, my second derivative is negative, meaning that the number that critical value is a maximum. So we know x equals 500 is maximum. When you plug it into the p demand function, you get 250. So now you know your equilibrium point. And now you can figure out your cost consumer supply function because you plug in the demand function here, and you plug in your p and your x here, and you go from 0 to x. Okay, and so when you integrate that guy, you get these two terms here, and you plug in 500 and you plug in 0 and do all the subtraction and combining, and you get 12,500. Producer's supply is this formula here, where the formula that you're using there is the surplus. Producer's surplus formula. it needs the P, it needs the equilibrium point, the X1, P1, but it also needs the surplus formula. Well, they give you P equals X squared plus 1 for supply, and they tell you the price is 20. So if you plug 20 into that formula, you can figure out what X is. It's either -5 or +4. X is the number of units. It can't be negative, so you throw that out. So you got 4 and you got 20 for your X and your P. So now we're ready to plug everything in here using the supply function here because it's surplus, so we're using supply. And we plug that in and we integrate properly and plug in 4 and 0 and do the subtraction. And we get 50.67, which is a dollar amount, and it's in millions of dollars. Same thing here with this one. They give you the demand and they give you the supply. So in order to find an X value, you have to set supply equal to demand. And when you square both sides and bring everything to one side, factor, set it equal to 0, you get two numbers, one of which is negative, you throw that out. So X equals 4. So now you go back and you plug 4 into that function there or that one there. It doesn't matter. You'll get 5 either way. So now you got X1, P1. And now you're ready to integrate, and you integrate using the supply function, which in this case is just X plus 1. Not that complicated. So you integrate and you get this, and you plug in 4, and then you plug in 0 and subtract the 2. And remember, you got 20 minus whatever this number is. And so you get 8, but it's in thousands of units, so it's really 8,000. Here they ask you to find consumer's surplus and producer's surplus. So we first have to find our equilibrium point by solving demand equals supply, and we take our two functions here, this one and this one, and set them equal to each other. And you can't really solve that one very easily algebraically, so we're going to use our calculator. Okay, so we're using our calculator, we type in y1 as the first function, y2 is the second. And then we hit window, and we want to change our window to probably something between 0 and 100. It usually is a good guess. X min is 0, X max is 100. You can leave everything else the way it is. Then hit graph. Then hit zoom 0, and you should be able to see a good picture of your graph at that point. So now to find where those two functions intersect, you hit second trace 5 for intersection, and you hit enter 3 times, and it will give you these two numbers. It'll give you 60 and 109.76. It won't say P1, it'll say Y1. But that is your Y coordinate here is your P, your X coordinate is your number of units. So you plug in your demand, which was the e to the X function, and you also follow it with P times X. And you got to integrate that guy, and so you got to add a 0.01, negative 0.01, and you got to divide that out as well. And so when you integrate, you get this guy here, and finally you subtract and you get that. Now that we know our X1, Y1, we can go right to our producer's supply, and we just have to integrate the other function, and we put in the front our P times X. And we integrate the supply, and when we do, and plug in our two values and do the subtraction and whatever, we get this number here. There's a couple of questions they ask you. It says, suppose a continuous income stream has an annual rate of flow given by this formula, and money is worth 7% compounded continuously. It says, create the integral used for income, total income. Well, it's just the function from 0 to 5. Okay? Then they ask you to find the present value. Well, present value is the function times e to the negative rt, and r is 0.07, so it's negative 0.07 t. And then c says the future value, and that one was e to the rt times the integral of the function times e to the negative rt. And you plug in all the things you know and simplify it as well as you can there. Number 2, suppose for a certain product the supply function is f and the demand function is g and the equilibrium point is x1, p1. Decide whether the following are true. A, consumer supply equals this. Well, the answer is false because the consumer supply uses the demand function, which is g. Number 2, B, producer's supply. Well, that one is false too, because it uses the producer's surplus uses the supply function, F, not G. Number 3, if demand equals this and supply equals that, and the market equilibrium is 910, create an integral for consumer surplus and producer surplus. So consumer surplus is just from 0 to 9, your integral, minus the x times the p, which is 9 times 10. And then the producer's surplus is x times p minus the integral from 0 to 9 of the supply function. Alright, so let's look at the similar questions from WebAssign. Question 4 says find the total income. So you integrate that guy from first 2 years, so 0 to 2. And you got to plug in a 0.02 and divide that out. And then you integrate and you get this number here. Same idea here. You're doing 0 to 5 and you're integrating that guy. And again, you have to bring in, sometimes you have to bring in a number so that it matches with your u and your u prime. And you also have to divide that out. And now when you integrate, you get this guy and you plug in 5 and 0 and subtract and you get your answer. Number 7, total income, same idea. You integrate that guy and you have to introduce a 0.004, so you divide out 0.004. And then when you integrate, you plug in 12 and 6 and do the subtraction. Consumer surplus, again we have to find x1, p1, and I think, well, they give us x1, which is 8, but they don't give us p1, but they give us p, and we plug in 8 for x, and we get p. So now we got our equilibrium point, and we can do the consumer surplus integral. So we use the demand function, and we follow it with p times x, and we integrate from 0 to 8, 0 to x1. And we integrate, and we get this, and its absolute value, natural log of absolute value from 0 to 8, and we subtract 160. And so we simplify that down, and we end up getting 161.89. The demand function is given, supply function is given, find the equilibrium point and the consumer surplus. So if supply equals demand, you solve that equation, throw everything to one side and factor, and you get two numbers, one of which doesn't make sense. You can't have a negative number of units, so 5 is your answer. You plug that into either equation and you get what the price is, which is 56. Now you've got your equilibrium point. Now you're ready to do consumer surplus, because you take the integral from 0 to x, you use the demand function, and you follow it with p times x, which is all this, and you integrate, plug in 5 and 0 and subtract, and you get 83.33. This one is asking you, this is where a monopoly has maximized profit. So you first have to find out where profit is maximized. Well, they give you the cost function, and they give you the demand function in terms of P. P equals this. So they don't tell you the revenue. But if they give you P, you can just multiply P times X and you get your revenue. So whatever the price is, you just multiply it times X and that's your revenue function. So you now know revenue, you now know cost, and you can subtract one from the other. And that's what you get for, that's your profit function. Take the derivative, set it equal to 0, and factor, and you find two answers, one of which doesn't make sense. So possibly you can maximize your profit when x equals 5. So you could either do a sign diagram and divide up the interval from 0 and 5 and greater than 5, or you can take the second derivative, plug that in, see if that will work, and it does. It gives you a negative, so that means that x equals 5 is a maximum. If it gives you a positive for the second derivative, that means it's a minimum. Alright, so we got x equals 5 as a maximum. We want to know what that profit actually is. We plug in into the price and we get 295. So what is our consumer supply? We just take the demand function and 0 to 5, which is our x is 0 to 5, and minus subtract p times x. And we integrate, plug in 5 and 0 and subtract, and we get 204.17. Producer's supply, that involves this equation here with the supply function. But again, you need to know your equilibrium point, and we know x. We don't know p. Well, we know p equals this, so you plug in 15 for x and solve it, and now you know what the price is. So here's your price, here's your quantity, so that's your equilibrium point, and you need that for this first term here and for this limit of integration there. You plug in the function 10e to the 1/3 x, which means if that's your u, 1/3 x, you need a 1/3 down here, and you need to divide by 1/3 or multiply by 3 out front. And then when you integrate from 0 to 15, so plug that in and subtract, and you get that number there. 31, it says find the producer's surplus if demand equals this and supply equals that. So set supply equal to demand and solve. You throw everything to one side, factor, set equal to 0, and you throw out a negative number of units because you can't have negative units, so x equals 5. Go back and plug 5 into either equation to get your price of 56. So now you got your equilibrium point, which you're going to need when you integrate here. So you multiply p times x, and you use x here for your limit of integration. You plug in the function that we're given here, or the supply that we're given here. And when you integrate, you get this, and now you plug in 5, and you plug in 0 and subtract. And then you get 280 minus that, which is 133.33.